In this video, we will discuss the linear function. This is belongs to the topic of the mathematical modeling, and this is part 1. Part 2 is talking about the quadratic function. Okay? These topics are actually one of the requirements to go for calculus, so we will give emphasis on the linear function and quadratic function in the part 2 of this video. Okay, modeling linear function. So the linear function is in the form of the fx, or the function of x, mx plus b, where x is the domain and we have the range as the function of x. So this function of x, actually the y value or the range, and x is the domain. M is the slope of the line, because linear function, the graph is a straight line, so we have the slope. The slope must be assigned to be small letter m, and this is the coefficient of the first degree variable, because when you say linear, the highest degree should be 1 of the variable. And the variable is domain. At any value of the domain, we have the corresponding values of y. Remember, this is a device linear function, where b is the y-intercept. So the slope is actually the rise over run of the line. If we have the line, then it must have the rise and we have the run. The ratio between the rise and run is the slope, or small letter m. Now the y-intercept, or small letter b, is the distance from the origin to the point where the line intersects the y-axis. What does it mean? If we have this Cartesian plane, x and y, so if this is the line, suppose this is the line, so this point, this graph intersect to y, measured from the origin, is actually the y-intercept. So the intersection of the graph, because linear function always crosses the y-axis. It can be positive y, negative y, or maybe 0. So therefore, there must be a y-intercept always. So we will assign that as b. Then okay, so the coordinate must be 0, b. The abscissa is 0, and the coordinate is b. At any point along the line, we call this as p. So it has the coordinate of xy, where x is the domain again, and this is y is the range. So for any value of x, there must be a value of y, because y is dependent to x, input, output. So what is x? X is measured from this point towards the horizontal projection towards y. Okay, so this is x, while y is the distance from the point towards the projected line along the x-axis. So therefore, this is y measured from the origin. X is also measured from the origin. So when you look at the linear function, y depends on x. So the slope is constant, the y-intercept is constant, so the only value changes is only the x variable. For any value of x, there must be a value of y. Okay, so take note that if we project a line here, horizontal, a vertical, so we have the horizontal, then this is actually a right triangle. So this is 90 degrees. So therefore, we can provide the slope, because the slope is the rise over run, the ratio of the rise over run. So we use this rise because this is actually labeled as xy, and we have this coordinate. So we need 2 points in order to provide the rise over run. So in this case, we utilize the given information. So this will be our rise, and this will be our run. So in this case, when you look at this one, what is the length of the rise? This one, it should be y minus yb. Okay, it should be y minus yb. Y subtracted by yb, or b, is equal to the rise, while the run is actually purely as x. So if therefore if we use the formula of the slope, the rise over run, substitute the rise, this rise substituted by y minus b, and your run is x, so therefore we come up with this. Okay, then diagonal product, we have mx is equal to y minus b. Solving for y transpose b, then we can have this is the linear function model actually. So this is the derivation of this formula. So if we are on the way to model a linear, then the requirements are we should have the slope and we should have the y-intercept if we will use this linear function model. So with that, we can provide the function of this graph, the linear function. Okay, so that's it. Now, suppose I have this line crosses to x and I have this line opens to the right, so the slope must be positive. When you look at the, if this is drawn to scale, so we have 1 unit here, another 1 unit, rise over run is 1, so therefore the slope of this line is actually 1. If you use this point and the origin, this must be 2 units. As the rise, the run is 2 units, so the slope is 1. So anywhere providing a triangle will provide the slope constant be equal to 1. And this is positive because this is open to the right. So we assume that open to the right, okay, then the slope must be positive. So therefore, in contrast, if the line opens to the left, it should be a negative slope. The greater the number of the slope, the steeper is the line. So steep because the rise now dominates with the run. If your slope is 1, so therefore the angle is 45 degrees. So if your angle is 45 degrees, the slope is 1. More than 45, it should be greater than 1. Below 45 degrees, so therefore the slope is less than 1. Okay, negative opens to the left. Now if the line is horizontal, what will be the slope? So if the line is horizontal, so there's no rise. So therefore rise must be 0. So 0 divided any number, the slope is 0. So for a horizontal line, the slope must be 0. Now what about if the line is vertical? If the line is vertical, you can notice that there is no run. So if there's no run, this must be 0. But take note, we cannot divide 0 number because it provides imaginary or indefinite number. So therefore, a line that is constructed vertically has no slope. But the line constructed horizontally is 0 slope. Now a little bit deflected from vertical, we have already the slope, but at that exactly vertical, meaning it is 90 degrees from the x-axis, so therefore it has a no slope. The line has no slope, so therefore it is not a function. It is not a function of x because it will not change with the value of x. Okay, so these are very important informations when we are talking about linear. Take note, linear means it is a straight line. The slope is, okay, it has a slope. And the variable is in a first degree variable. X is in first degree. It should be raised to 1. Now, if two lines are parallel, suppose we have line M1, the slope is 1/2, so you can notice here, drawn to scale, this is 1, and this is 2 units, so this is 1/2. Positive because opens to the right. Suppose I have another line, and this line is parallel. So if you know this as 1/2, and this is, the two are parallel, then automatically, this is also equal to 1/2. Because lines that have the same, parallel lines have the same slope. So M1 is equal to M2. So since we know that this is 1/2, then this must be 1/2. Vice versa, if you know the slope of the line 2, then you can provide the slope at the line 1. Okay? parallel lines have the same slope. What about perpendicular line? Now, if two lines intersect perpendicularly, so therefore, uh, parallel, the same slope. But what will happen if the two lines intersect perpendicularly? What will be the relation of the slope? Okay, the answer is the slope of line 1 is the negative reciprocal of line 2. Vice versa. We can say also that the slope of line 2 is a negative reciprocal of the slope of line 1. That's it. This is the relationship. Okay? No need to derive. So, meaning, if we have this line having a slope of 1, this is the slope of the line 1. Now, suppose you are constructing a vertical, perpendicular line to this line. So, therefore, the slope will be automatically equal to, take the reciprocal. What is the reciprocal of 1/2? Negative reciprocal. So, therefore, the answer is negative 2. Okay, so the slope must be of negative 2. This must be 90. If it is perpendicular, this must be 90. So, automatically, this must be 2. When you examine the graph, this is 2 units and this is 1 unit. So therefore, rise over run is 2. And this is open to the left, it should be negative. Okay? These are the things that we need to remember if we studied linear functions. Because you might be encountered, the usual question in the problem is, in modeling is, you have to provide the equation of that line. So, derive or provide the linear modeling from this given. So, with that, then there are informations that the two lines are perpendicular. Then, again, we can use this. Or parallel lines. Okay? So, take note that when we say rise over run is delta t, delta x over delta y over delta x. It should be the rise. Delta means change. Okay? Suppose we have this point. Let us say this point is point 1 whose coordinate is x1, y1. Then point 2 whose coordinate is x2 and y2. Now, what is the slope of the line? What is the slope of the line? All you need to do is to provide this triangle. So, you have to construct vertical line, horizontal line. The intersection must be 90. So, therefore, this distance must be changed in y and this is changed in x, or delta y, delta x. So delta, take note that, look at this one, delta y is what? Remember that this point is actually y2 from the origin. And this point is actually y1 from the origin. So therefore, to know the change in y, it should be y2 minus y1. So y2 minus y1. So, y2 minus y. What is change in x? You know that this one is actually measured at x2 from the origin. So, this must be x2. And this must be x1. So, if you want to know this line, take note that this is the same as this one up to here. So, it should be x2 minus x1. So, that will be our rise. Okay. So, then, all you need to do is to substitute, then you will arrive the answer. So, suppose this is point 1 has a coordinate of 1 and 1. So, this is abscissa coordinate. And this is point 2, 3 and 2. So, you can notice here, this is drawn to scale. This is 1 unit and this is 1 unit. This is 3 units of x, 2 units of y. So, therefore, 2, 3. Calculate the slope of the line given these two informations. Okay? Very easy. Your y2, you can choose any. You can use this point 2, point 1. So, if this is point 2, this should be x2, y2. If this point 1, it should be x1, y1. But this one, I assign this as point 1 and point 2. So, therefore, this must be x2 and y2. So, therefore, substitute the values of y2. Look at the given. y2 is 2. So, therefore, this must be 2. Then, y1 is this one. This is the y1. So, this should be replace this. Take note, this is always minus. Okay? So, if this is minus, then you have to minus. For x2, okay, x2, go back to point 2, this is 3. So, this is 3. x1 is 1. So, then, substitute. then this is 1 half. So the slope of this line is 1 half or 0.5. That's it. So you know the slope, okay? Or you can change the one. You can provide another point. So for example, I have here another point. This is x negative 1 and we have 3. Okay, if you reverse this, so this is 1 and this is 1. Okay, so that's it. This is 1 half. So I think this is enough for us to calculate the slope using these 2 points. Okay, so then they must have the same slope. If you use another point is actually the x1 and y1. Okay, now what is the linear function model? So we know already the slope, that is 0.5. Then we are asked to find the linear model. So what will you do? Okay, use this one. Now what is your y-intercept? That's the question. So in this case, the y-intercept is 0.5. When you look at the graph, this is 0.5 and this is actually exactly at negative 1. So by just looking at the graph, this is 0.5. So therefore, substitute these values to this linear function model, then we have the model, or the linear model is 0.5 as the slope plus x times 0.5 as the y-intercept. Okay, so this is the answer to the question, linear model a linear function. So the requirement is we need the slope and we need the y-intercept. Okay, by the way, this one is actually taken from this point because we have x is equal to negative 3, y is 1. So we use another point. You can assign any point. You will have the same slope. You can use also this one. This is 0 and negative 1. So this is 0, this is 0, and this is negative 1. So then you will arrive still 1 half. Okay, so this is the model. Now, this is the standard equation actually. This is linear function. So function of x or mx plus b is equal to mx, or y is equal to mx. This is linear function. Now, it can be transformed into linear equation. So this is a kind of linear equation. This is the left member and this is the right member. The left member contains the variables, so x and y, and this is constant actually. So in this case, this is the constant b. If you transpose this to the right, then you can create a standard form of linear equation. So a and b, a, b, c are real numbers. This should be real numbers, no imaginary numbers, in order to come up with a function. So this is a standard form. Other forms also, because c can be 0. So if it's 0, what will happen? We have only ex plus by is equal to 0. Or it can be a is 0. So b also can be 0. So therefore, in this case, remember this, there should be at least one value. So therefore, b can 0 or a can be 0. Because if both b are 0, then there is no linear function. So in that case, we have by plus c. So this is still linear function. B cannot be equal to, by the way, b cannot be equal to 0 because we are on the function. Because if this is 0, y is equal to 0 also, though non-linear. Okay, we have this example. Model a linear function if its y-intercept or b is equal to -3 and the slope is 7. Then transform to standard linear equation. So how will you answer this problem? Okay, to answer this is to use the linear function model. We are given with the slope and given slope 7, the y-intercept is 3. So substitute everything in this formula. This must be 7 and this must be -3. Take note, substitute algebraically. So means to say that you have to include the sign. So therefore, substitute it algebraically. Then we have m as 7 is equal to 7x plus b is -3. Then simplify. We come up the model. This is y is equal to 7x minus. This is linear function. Okay. So this is linear function. Now what about the standard linear equation? All you need to do is to transpose this y and transpose this x, then rotate. So we come up with 7x minus y is equal to 3. This is the standard. Why standard? Because this is constant. The right member should be constant. Variable should be at the left side. And it should be start with x. And it should be start with positive. If it is negative, you have to reverse it. Okay? Or take the additive inverse. Okay, so that's it. We have this. Now, there is another important information when we are studying linear. You should know the 4 forms of linear equations. 4 forms. So, the linear function is already one of the form. So, this is actually in a form of slope-intercept. Slope-intercept form. Remember, this is our linear function. Y, m is plus. But this is a slope-intercept form because this is a slope and this is intercept. This is one of the form of the linear equation. Another is we have the 2-point form. So 2-point form, it has an equation of y minus y1 is equal to m times x minus x1. This is a kind of equation which is again a linear. Another form is we have the 2-point form. So this we call this as point slope because m is the slope, point is x1 and y1. Okay? X1 and y1. The x and y is the variable, are the variable. So therefore, we cannot substitute this one. So leave this. This is at any point. So there in a linear equation there must be x and there must be y. So without subscript means they are called as the variable of the linear function. So in this case, there's no subscript of x, so therefore this must be the variable x and the variable y. So m are numbers, exact numbers, and b. Now the 2-point form means we have 2 given points, so we can notice that we have the subscript of 1 and subscript of 2, both x and y. So therefore, y1 and x1 are the coordinates of point 1 as 1 point. The other point is subscripts with point 2, with 2. So x2 and y2 are the coordinate of the other point. So we have 2-point form. Now the x without subscript again and y without subscript are the variables. So there must be a presence of this 2. You cannot substitute this one. All you need to do is to substitute the given values. So if given the 2-point form, then use it. Then after that, you can come up with a linear equation. Finally, in the 4th form of linear equation is the intercept form. So the intercept form, it has an equation of x over a plus b over y over b is equal to 1. The x and y again are the variable, where a is the x-intercept. So when we say x-intercept, it is where the point of the line crosses to the x-axis. Where b is the b that we assigned in the slope-intercept form. So this is y-intercept. So when we say y-intercept, it is the point where the graph intersect along the y-axis. So this is the intersection of the graph at the x-axis is a, but in a y is b. So this is x and y intercept actually. we call this as intercept form. So the formula should be x over a plus y over b is equal to 1. This is always 1. So what's the use of this? The use of these four forms will help us to formulate or model the linear function. We can create equations. Okay? Or, vice versa, from equations, we can provide the slope, we can provide the y-intercept, and other informations. And we can graph the functions. So, this is a very important relationship if we studied about linear function. You should know this formula. And the most important is you should have the idea to derive this one. So we will derive these four forms, then we will provide an example so that you will learn how to use the four forms of linear equation. Okay? So let's start with number 1. This is actually nothing to worry. We derived this in our previous slide. So it's already done. So this is, remember, a slope, m, y-intercept. So we have this line, we have the slope given, and we have this y-intercept. So we derived this previously. So therefore, this is b, and this is at any point. So the x and y is, there must be at any point p without subscript. So therefore, you cannot replace it. So then, for example, using this slope-intercept form, the question is find the slope of the y. Find the slope and the y-intercept of the given. This is the given equation for x minus 3y plus 5. Then after that, solve also x and y. By the way, the x and y are the domain and range respectively. So the only question is find the slope and find the y-intercept. Slope is m. So we will solve m and we will solve the y-intercept b. So how will you do it? Very easy. Use the equation. This is the given. All you need to do is to transform this into slope-intercept form. Because if you transform this equation given for x minus 3y is equal to 5 in this form, then we can easily pick up the slope and pick up the b. Remember, the number adjacent to x, or the coefficient of x, is the slope, and the constant without variable is the y-intercept. So do it. So from here, transpose x to the right becomes negative for x. Remember the lobe algebra? So transpose to the right side, this will becomes negative for x. And next is, okay, we have already transpose the 4x. So we have this negative 3y. So all you need to do is to divide both sides by negative 3 in order to come up with y. So divide both sides by 3, negative 3. This will becomes 5 over negative 3 minus, because it's minus, 4 over negative 3x. So then, simplify. Take note, negative is actually plus, and this is negative. So the answer, or if you arrange this one, this will becomes 4x. So because x is in the first term, so this will be, you interchange, this is negative becomes plus of 4 over 3x minus 5 over 3. So look at this one. This equation is already in this form, slope-intercept form. So therefore, we can easily pick up the slope. So the 4 over 3 is the coefficient of x. So this must be our slope. Okay? Very easy if you know the form. Then the entire value, this including this one, is actually the y-intercept. So therefore, this must be negative 5 over 3. If you answer it positive 5 over 3, then you are wrong, because it's negative, remember. So you have to consider whatever sign. If this is positive, then it is a positive 5 over 3. And these are the answers to the question. So we can easily answer this one, provided we have this number 1 form of linear equation, which is the slope-intercept form. Okay. Now, again, if you reverse this, given the slope, given the y-intercept, you can derive the equation, vice versa. Just like what we did in the previous slides. Okay. So, form number 2, point form, point slope form. So we have the point is point 1, and the slope is given also. And this is x, y. So, in the graph, suppose this is the line, there must be a point here, and there must be a slope. So, this is point 1 and slope. So, this is a kind, if this is given the slope, and given this one, we call this as point slope form. Okay. So, at any point, we have to construct at any point along this line. Call this as P, X, Y coordinate. So then, again, construct the change in Y and the change in X. The change in Y in this case is what? This is Y minus, remember, change in Y. Okay? This is Y, because this is Y is from the origin towards this point. And this is y1. So this change must be y minus y1. While this one is x minus x1. So then, use the formula for the slope. Okay? Because slope is rise over run. So, we come up with y minus y1, x minus x2, x1. Then, transform this one, diagonal product, you come up with the number 2 form. The point slope form, diagonal product. So we have the y minus y1 is equal to m times x minus x1. That's it. This is the very easy to derive. Now, I encourage all of you to do not use a formula if you cannot derive. So you should know how to derive, because if you can derive, you will understand the entire concept of the problem, or the principle of that problem. Okay, so that's it. So suppose we are given this, suppose this point 1 is given as negative 2 and 3, and given the slope is negative 1/2 or negative 1 over 5. So therefore, negative means open to the left. So what's the graph is? Okay, it should be open to the left. Now, solution, for your solution, you have to substitute here. Remember, this is point 1. So this must be x1, y1. So substitute it here, 3. And the 2 must be negative 2 at the x1. Remember, this is minus. So it should be minus 2. And the slope is negative 5. So substitute. Do not substitute x and y again, because this will brings you to an equation. These are the variables. So substitute to this form, point slope form, then this is the result. Y is the y variable, y variable. This is negative 3 for the what? For the y1. So negative, this is negative and this is positive. So minus plus 3. And this is equal to the slope is negative 1 over 5 multiplied by x minus, and this is minus. So use your algebra. Minus minus becomes plus. Okay? Then transpose this 3 to the right side, becomes plus. So if you are because the question is find the functions, automatically linear function. So you have y here. So y is equal to negative 1 over 5. Okay? X. And this is minus, because this is minus minus plus, but this is minus. So this should be what? This should be 2 over 5. And this 3 must transpose. So we need to combine this one. So negative 2 over 5 plus 3, this will come up with 13 over 5. So use your fraction, combining fractions. So, okay, so this is the answer. So look at this one. Actually, this is the slope. This is the slope, negative 1 over 5, which is given. And this is the y-intercept actually. But the question says, find the function. So this is enough. So the graph, what's the graph? You are asked to graph. So the point negative 2 and 3 is located in the second quadrant. So negative 2 and positive 3. Because in the first quadrant, all components or the members are positive. This one, second quadrant, negative, positive. In the third quadrant, all are negative. In the fourth quadrant, positive x and negative y. Okay? So this point should be located at the second secant quadrant. Okay, then another given is the slope. So you have to, slope means rise over run. So we have the rise 1. Okay, we have the rise 1 and we have the run 5. 1, 2, 3, 4, 5. So therefore, this must be the line. This must be the line. Rise is 1. This is 1. And the run is 5 units. So 1, 2, 3, 4, 5. That's it. This is the, and this is negative. So therefore, this is the graph of the line. So therefore, this one, y-intercept is 13 over 5. Excuse me. Okay. So then, next is form number 3. So the form number 3, again, our previous slide, this is y minus y1 is equal to y2 minus y1 divided by x2 minus x1, quantity x minus x1. This is 2-point form. So there must be 2 subscript here. We have the subscript of 1, subscript of 2. The subscript of 1 means the point 1. The subscript of 2 means the coordinate of point 2. Okay. So suppose this is point 1. Call this as x1, y1. And this is point 2. And we have x2 and y2. Okay. Now, at any point along this curve, along this line should be x, y. So we can put it here anywhere. So at any point along this curve, so we choose a point in between the 2 points. So with that, if you want to derive this one, why is it that this is the formula? Okay, nothing to worry. Look at these 3 points. Now from there, you can provide the proof using the previous. There are many ways to derive. You can use the point slope form because we already derived this one. So all you need to do is to solve for m. The slope, remember, is what? Look at this one. The slope can be calculated with numbers. Remember, given point 2 and point 1. So therefore, the rise should be y2 minus y1, and the run must be x2 minus x1. So substitute the slope, then that's it. As easy as that. So this is now the, recopy this one, copy, and we change only the value of slope, or the slope in terms of the given points. So it should be y2 minus y1, x2 minus x1. So very simple derivation. Okay. Example. Suppose now the point are, we have this point 1 or 1. This is, by the way, this is drawn not to scale because this is supposed to be, the point should be located at this point. Anyway, nothing to worry. As long as given point 1 is 1, 1, on point 2 we have 3, 2. So then, all you need to do is to substitute. What is your y2? Your y2 is y1. This is y1 because it's at point 1, so it should be 1 substituted here. So do it. Change that. And that is 1, 1. Okay, next. What is x1? This is x1. So x1 should be replaced it here. Okay? So then, do it. Change it. Then, at point 2, this is y2. So, replace it with 2. Then, this is x2. Then, replace it with, this is x2. So, therefore, replace it with 3. That's it. Do not replace x and y again. Again, reminders. There must be x and y without subscript. So, then, simplify. This is 2 minus 1. This is 3 minus 1. So, we come up of 1 over 2. Okay? So, this is 1 over 2. And this is, okay. This is 1 over 2. Distribute it here. So, therefore, 1 over 2, x. 1 over 2 times y. And this is, remember, this is, okay. This is 1/2. Okay? Distribute 1/2 x. Distribute 1/2. Okay. What negative 1/2. But remember, we have 1 here. Transpose to another side becomes 1. So it should be negative 1/2 plus 1. What is negative 1 half plus 1? The answer is 1 half. So the final answer is y is equal to 1 over 2x plus 1 plus 1 over half, 1 over 2. Okay? This is the slope, and this is the y-intercept. Okay. Last form. We have the intercept form. The intercept form, again, in our previous slide, we have x over a, y over b is equal to 1. So, if that's the case, then suppose, by the way, this is the, if suppose this is the line, so the line it intersect along y is b, and the graph of the line intersect along x-axis is actually a. So this is y-intercept, and this is x-intercept. So all you need to do is to whatever this value, substitute it here, substitute it here. So then you will arrive the answer. So it has a coordinate of a and 0, and this is 0 and b. Actually, in mathematical explanation or this definition of x-intercept, it is where when x-intercept is it is where when y is equal to 0, while the y-intercept, it is located where x is equal to 0. So the coordinate must be 0b and a 0. At any point along the point, then we have this p. So suppose we are asked to solve for determine the x and y intercept. So when we say x and y intercept, you are asked to solve what is a and what is b, not x and y, because x and y are the variable. So the question here, what is the x and y intercept of the equation y is equal to 4x plus 5? Okay, so do it. You need to transform this one. All you need to do is to transform this given y is equal to 4x plus 5 into what? Into an intercept form. Because from there, if this is already in the form of intercept form, then you can easily pick up a and pick up b. So therefore, this should be 1. So all you need to do is what? Transpose x to the left. Okay? Then the right member becomes only 5. So it's constant, but remember this is 1. So you have to divide both sides by 5 in order to come up with 1. So do it. So transpose 4 becomes negative 4x, and this is plus y, this is y, and this is 5. All you need to do is to divide by 5 both sides. So this should be divide by 5 becomes 1. Divide by 5, 1/5. Divide by 5, 3 negative 4 over 5. Okay? That's it. Now, again, this one can be, this is negative 4 over 5. So this can be rewrite as what? X over negative 5 over 4. Because if you, this is a mixed number. So if you reduce this mix, this will arrive as negative 4 over x. So you need to transform in this case for fraction. Why? Because we want to adapt the intercept form in order to solve for. So doing this one is actually solving for a and b. So this one, the entire value of this, the denominator of x is a, and the denominator of y is b. So we can easily pick up. So a, therefore, say it as negative 5 over 4, and b is 5. That's it. Very simple. Okay? So remember that from the equation, we arrive this a and b. If you reverse this, suppose you are given this a and b, all you need to do is to substitute it here, then transform or simplify, then make it as required by the problem. So suppose the problem says that find the equation, so you have to present this in a standard form, or find the linear function, then this must be the answer. Vice versa. The most important is you know the principle of the intercept form. The question is how this form derived. So we will derive that. Oh, no, not. We still have the example. So suppose the x and y intercept are given. So x intercept is negative 2, 4 respectively. This is a and this is b. Then find the slope and the y-intercept. Actually, this is already the answer. So first question is find the function given the a and b. So when you construct the graph, so this must be the y-intercept, x-intercept, so negative 2, and the y-intercept is 4. So connect a line. That's it. That's the graph. Okay? So this is 2 and 4. So then all you need to do is to remember the coordinate of here is negative 2 and 0, and this is 4, 0. So at any point is actually x and y. Now for your solution, because the question is function, so all you need to do is to substitute here. So negative 2 and 4. That's it. Then remove the denominator. To remove this denominator, because equation doesn't have the denominator, so multiply both sides by 8. The common multiple is 4. So multiply both sides by 4. Okay? Or you can transpose this one to the left side, becomes positive. Okay? The entire becomes positive. Then all you need to do is to multiply both sides by 4. Okay, then that's the answer is 2x plus 4. So this is the answer. And the follow-up question is what is the slope and the y? So the slope is 2 and the y is 4. So this is, remember, actually the y-intercept. So consistently we arrive this answer. And the answer is 2 and b. Okay. Now, the derivation, the proof of the intercept form. Okay. Suppose the line opens to the left and it intersects along positive A and positive B. So this must be the line. So the coordinate of at this point is B, A, 0B, and this is A0. And this is at any point. So with that, okay, you can use the 2-point form. There are many ways to derive. You can take ratio and proportion of the triangles. There are a lot of derivations. We choose to have this one, utilizing the 2-point form. So all you need to do is to solve. Remember, this is slope, and the slope is given. In this case, the slope is rise over run, so it should be b over a. So this must be b over a. This must be b over a. And minus. Okay, so that's why if you substitute b, this is the y2, and this is y1, so b minus 0. Then we have this one 0 minus a, and x1, you can choose any point here, so we choose this point. Okay, this point, so this should be 0x, and this is y1 is b. Okay, so if you can follow, substituting by just substituting this 2-point form from this given information here, then that's it. Then simplify again. As I've said, the slope is just b over a, and opens to the right, so this should be negative. So then transpose this one. Okay, what will you do is we want to derive this one. So all you need to do is to transpose b to the right side, and x should be at the left side, so that it will be in the form of, in the left are contains variables and the right is constant, so b is constant, so b should be placed at the right. Okay, and this should be placed at the left side, so becomes plus. So look at this one. We need to have this should be 1. So all you need to do is to divide both sides by b. Okay, or in this case I multiply both sides by a. If I multiply both sides by a, this will becomes bx plus ay is equal to ab. Okay, now this time we will make this as 1. So in order to provide 1, you have to divide both sides by ab. So divide both sides by ab, this will becomes 1, and this is ab. Remember, divide both sides by ab, so this should be ay over ab. So ay over ab means you can cancel the a. Okay, so cancelling a, we have only b. This one, divide both sides by ab, you can cancel b, so we have a. This is the derivation. Okay, so again, if you can derive the formula, then you understood the process. If you do not use the formula, if you cannot derive, because you can easily forget the forgot the formula. But if you can derive, you can easily recall. Because if you cannot recall, you can derive. That's it. Okay, so in summary, again, this in studying about linear function, we need these four forms of linear equations. Okay, so that's all. Thank you for listening. The next video is still on the modeling, but we will study the quadratic function.